Today we have Paul Halpern. He's a professor at the University of Sciences in Philadelphia, and he's got quite a bio. He's written 14 books and has one here today, so he will be selling and signing books for you. He's written books on subjects like space-time, higher dimensions, dark energy, dark matter, exoplanets, particle physics, and cosmology. And he's won many awards, the Guggenheim Fellowship, the Fulbright Scholarship, and the Athenaeum Literary Award. Okay, he's a regular contributor on a blog you're probably familiar with. It's Nova's Nature of Reality. And he's appeared on numerous radio and television shows, including Future Quest and The Simpsons 20th anniversary special. So we are very lucky to have Paul here today, and please help me in welcoming him to LVH. Paul.
Okay, so today I'm going to be talking about my new book, Einstein's Dice and Schrödinger's Cat. I wanted to thank Diane sincerely for inviting me here. It's very exciting to be here speaking to the group for the first time for this wonderful series, Sunday series. Next. So this year we're celebrating the life of Albert Einstein. It's a number of major anniversaries in the life of Einstein. First of all, it's the 200th anniversary of his masterful theory of gravity called general relativity. It's also the 110th anniversary of what was called his miracle year, where he wrote more than 7 papers, and including work that was noted for the Nobel Prize, the photoelectric effect, which is now part of digital cameras. He developed special relativity, and of course, his famous equation E equals mc squared. That was 110 years ago. Now, 80 years ago, he developed something called the EPR paradox, which was a critique of quantum physics. And finally, 60 years ago, it was the anniversary of his death. So he died in April 1955. So we commemorate that, despite the fact that he died more than 60 years ago. He is still an iconic figure. So if you see his face, almost everybody who would see his face on a t-shirt or a poster would still recognize Einstein. Einstein is one of the most recognizable personas of the 20th century. He is still very well known through his image, through his works, and still synonymous with genius. Now, this talk is not just about Einstein, it's also about another figure, this fellow here, Erwin Schrodinger, who became friends with Einstein, dear friends, close enough that they called each other something like brothers. But then, as we'll see, Schrodinger became egotistical. He realized that he could beat Einstein, and he turned on his mentor. So this is a tale of friendship, but also intrigue and betrayal. Next. Now, we don't really know Schrodinger by his face. If you saw a Schrodinger t-shirt, most people would not recognize Schrodinger or recognize his accomplishments or even why he got the Nobel Prize. People don't know these things. But today, his cat has become what's called a meme, something that has been almost virally infecting the internet in terms of interest. And we see his cat in so many places, on t-shirts and in TV programs. It's just become something that is very popular, the idea of Schrodinger's cat. It's become a symbol for ambiguity. In fact, some years ago, in a previous presidential election, a candidate who was running against Obama, I won't mention his name, was called the Schrodinger's candidate because he took so many contrary positions. But won't mention who it was. But anyway, I'm not going to be talking too much about Schrödinger's cat itself in this talk because I'm talking more about the personalities. But briefly, the Schrödinger's cat paradox was designed as a kind of ridiculous, nonsensical critique of quantum physics. And the idea is that you entangle, which means tie together, the state of a cat, the life of a cat, with the state of a particle, whether or not a particle decays or not. Quantum physics purports to explain what happens when particles decay, and Schrodinger thought, well, let's ludicrously apply this to an animal and see what happens, and take quantum physics to this extreme and show some of its limitations. So Schrodinger imagined that inside a closed box, there was a cat, a vial of poison, and the vial of poison would be released only if a Geiger counter registered the decay of a particle. So if a particle decays, the Geiger counter would tick. That would release a hammer. The hammer would break open the flask would release the poison, and the cat would die. But if that doesn't happen, the cat would survive. Well, if you place a sample, radioactive sample, in a box, according to quantum physics, because it's a subatomic particle, it is in what's called a superposition or mixed state of possibilities until you observe it. So standard quantum mechanics depends very much on the role of the observer. We say that it's in a mixed state of decayed and not decayed until you observe it and measure it, and through the act of measurement, the state purifies itself into either decayed or not decayed. Now, quantum physicists thought this made a lot of sense, and in fact it worked. It works all the time. When you measure something, all of a sudden it registers whether it's in one state or the other state. Before you measure it, it's in a mixed state. Well, Schrodinger imagined the cat's fate tied to this, and then the box being closed, and until you open the box, the cat is in a mixed state of dead and alive. In other words, it's kind of a zombie cat, which seems to be appropriate for this time of year to be talking about zombie cats. So it's a very Halloweenish kind of thought experiment. So that is the cat thought experiment. That's what Schrodinger's mostly famous for today. Next. Now, Schrodinger's cat, as I said, has become very popular. Those of you who are familiar with Monty Python might know about something called the parrot sketch, where somebody brings in a parrot to a pet shop and says this parrot is deceased, and the pet shop owner says, no, it's just resting. Well, in this case, a parrot could be in a mixed state of resting and deceased at the same time, a mixed quantum state. So this is Schrodinger's parrot. Next. So it's kind of interesting to note that Schrodinger's life, which is little known, as I said, was in a way as contradictory as his cat. So Schrodinger was a man of many, many contradictions. So the contradiction started when he was born, because he was born to English-speaking mother, German-speaking father. He grew up bilingual, but then learned numerous other languages. He became adept at many different languages, which is great. He got married, 2 ceremonies, a Catholic ceremony and a Protestant ceremony for different sides of his family. That's fine. When he did his degree, it was experimental physics mixed with theoretical physics. But then when he got his degree, he said, oh, maybe I'll be a philosopher. So he didn't know what he wanted to study. He was, in some ways, kind of a Renaissance man, in some ways, a man of contradictions. He would go to some groups and call himself an atheist, but then he would talk about divine motivations and the divine reasons why he was doing his work. And he thought that there was kind of a God-given reason for things that he was doing, even though he would say he was an atheist. He would go to a conference, scholarly conference, dressed like a backpacker, and sometimes not even be let into the conference. And these were the days where everybody was wearing a suit and a tie to a conference. He would walk in dressed like he was about to hike across the mountains, and people would have to vouch for him to let him into the conference. But then he would take time to go to the beach, and he would dress in a suit and bring a blackboard to the beach. And perhaps one of his biggest contradictions was in terms of his life partners. He kind of couldn't make up his mind. He had a wife who he was legally married to, but then over the years, different women came into his life, and at one point when he was living in Ireland, he effectively had 2 wives. There were 2 women living with him. One was his legal wife, and one was the woman who was taking care of his daughter. and the mother of his daughter. And he didn't see this as a contradiction. He saw this as just part of where life takes you. He was motivated a lot by the works of Schopenhauer and the idea that you kind of go with the flow, that life is full of forces that take you to different places, and you kind of go with whatever life presents you with. Next. So the physicist Walter Turing, who worked with Schrodinger, said it was like he was always being chased from one problem to another by his genius, from one country to another by the political powers in the 20th century. He was a man full of contradictions. He never really lived in any place very long, except for Ireland. But almost every other country he lived in, he would kind of move on. Next. So the two protagonists of my talk and of my book met at a conference in 1913. Schrodinger already had his degree, his PhD in physics. He was thinking of doing more applied work, but then he saw Einstein, and there was a revelation. Suddenly, Schrodinger wanted to do something more theoretical, more fundamental. Because Einstein gave a talk to this major meeting in Vienna that was organized by the Habsburgs, the Austro-Hungarian Empire, and they had been around for a very long time and had lots of money, and they hosted a very lavish conference in Vienna for German-speaking scientists and physicians. And it was this huge conference. No expense was spared, lavish dinners, and so forth. Within a couple of years, the Austro-Hungarian Empire was no more. So that was because of World War I. It wasn't because they overspent at the conference. That, as fate would have it, that was the last scientific conference organized by the Austro-Hungarian Empire. Next. So Einstein spoke at the conference about a theory he was developing on gravitation that would supersede Newtonian theory, which was kind of shocking in those days because Newton was revered as kind of one of the icons of physics. So to tear Newton's theory apart seemed very, very daring. Next. So the reason Einstein wanted to overturn Newton was not because Newtonian theory proved unsuccessful. In fact, on the contrary, Newtonian theory was extremely successful. But Einstein thought that it didn't make sense because it was non-local. Einstein thought that everything should be local. So by that, what I mean is that Newtonian gravitation imagines two objects connected by an invisible thread. It imagines that the Earth and the Sun are connected somehow by this string which is pulling on the Earth. Not a real string, but this imaginary force that's causing the Earth to stay in orbit. If the Sun disappeared, according to Newtonian physics, the string would immediately snap, this force would disappear, and Earth would start traveling in a straight line. Einstein thought that this didn't make any sense. How can things happen over a great distance? It's almost like telepathy. And Einstein had a lot of suspicion of the supernatural ideas of telepathy, clairvoyance, and so forth. A lot of people tried to associate him with psychic ideas, but he was very much against that, very much in favor of natural explanations. And he saw the idea that things could influence each other instantaneously over a distance as anathema because it almost seemed like a kind of mind reading. So if the sun disappeared, there would have to be some time for the signal to travel to Earth, Earth to know about it, and know that it should start traveling in a straight line. And that amount of time should be at least 8 minutes, because that's how long it takes for light to travel from the sun to the Earth. And in fact, Einstein's earlier theory of special relativity said nothing travels faster than light. No signals travel faster than light. So therefore, gravity should not travel faster than light. It should happen in waves. And that was Einstein's idea, that gravity is ripples, that it's something in which the geometry of space itself is rippling and warping and turning. That's Einstein's idea. Next. So Einstein's talk stimulated a lot of people, including Schrodinger, to start pursuing theoretical interest and to start looking at fundamental questions. And Schrodinger started working on general relativity, trying to find solutions, and he was really interested in this idea. But unfortunately, as I mentioned, World War I happened the next year. Einstein was a pacifist. He did not have German citizenship at the time, so even though he was living in Berlin, he wrote out the war and was very critical of the war. He circulated a petition to say that the war was ludicrous, World War I was ludicrous. Schrödinger was forced to serve in the Austro-Hungarian army, so he became an army commander. Next. So Einstein took the opportunity during the war to finish his theory of general relativity. And briefly, in a nutshell, general relativity says that matter tells space how to curve, just like if you took a sheet, like a trampoline, and put something heavy on it, like a heavy rock, you would see distortion. So that's what the sun is doing to the fabric of space-time near the Earth. Now, when you distort something, things no longer can move in a straight line. So if you have a trampoline and you put a rock on it, and then you take a little ball and try to roll it, the ball is not going to roll in a straight line, but it's going to start curving around. And that's exactly what happens to the Earth. The Earth curves around. It wants to move in a straight line, but because of this gravitational well, because of the warping of space-time, the Earth moves in an elliptical orbit, a near circular orbit around the sun. And the same with all the planets. Next. Now, Schrödinger learned about Einstein's theory of general relativity while he was in Prosecco, which is near the border with Italy, then border with Italy, and the Austro-Hungarian Empire. And he was commanding a battery there. And you see Schrödinger commanding the battery, and he did some reading at the time. Soon thereafter, he went back to Vienna and was still doing war work. But once he was back in Vienna, he was able to start working on looking at general relativity and working on his theoretical work. Next. So one really cool thing about Einstein's general theory of relativity is it makes a prediction that can contrast with the Newtonian prediction. Now, if you imagine that light is carried by particles, and you imagine that the particles have a tiny bit of mass, then Newtonian theory predicts that the particles would curve if they were near the sun just because of gravity. Okay, including light from a distant star. Now we know today that light is carried by massless particles, so this wouldn't really work. But hypothetically, you can imagine a Newtonian scenario where light is distorted when it's near the sun. Now, Einstein's theory predicts twice as much distortion as Newton's theory. So Einstein said, to test my theory, wait until you can see the sun and a star near the sun at the same time, and the star's light is going to deviate because the light is curved by the sun. So when you look at the star, it's in the observed position rather than the real position because its light is bent by the sun, as in this diagram here. So in order to test this, you could do this after the talk. You just go outside, look carefully at the sun. I guess you shouldn't really look at the sun, so I can't give this advice. But if you could, and there's a star right behind it, you can see that the star is in a false position. I forgot one thing. You can only do this during an eclipse because it's very light out, so you can't see any stars right now. But if there was a solar eclipse, then using special glasses or specially protected telescope, then you can look to see stars near the sun, and their light would deviate, and the stars would be in a different position than you would expect if the sun weren't there. So this is one of the key predictions of Einsteinian relativity, that during an eclipse, light is deviated or bent by the presence of the sun because it's a massive object and distorting space-time. Next. Now, this was tested after the war in 1919 by two teams of astronomers led by Arthur Eddington, who was a pretty remarkable figure. He was a Quaker, a pacifist, and he was one of the few people in England who collaborated with Einstein during the war, two pacifists collaborating despite the animosity between their countries. After the war, he realized that the idea could be tested during the 1919 solar eclipse, May 1919. So they tested it, measured it up against the Newtonian prediction, and found that it fell much closer to the Einsteinian prediction than the Newtonian prediction, that the deviation was twice as much as the Newtonian prediction. Next. So that's Einstein with Eddington later on. By November 1919, the Royal Society analyzed Eddington's results and announced quite remarkably that Einstein's theory had overturned Newtonian theory, which I think is very, very remarkable given the fact that World War I had just ended and that Britain had been fighting against Germany, and now for the Royal Academy, the Royal Astronomical Society, to say that Einstein, a German's work, was more accurate than Isaac Newton, who was an Englishman, was very, very remarkable. But they were brave enough to say that this is where the data falls and that Einstein's theory is superior. Next. So global headlines, not just in the New York Times, the London Times, all around the world proclaimed the Einsteinian revolution. It was very remarkable. He went overnight from being an unknown scientist to being world famous, November 1919. So here we have the New York Times headline. So imagine a Sunday back in 1919, you pick up your New York Times, open it up, and it says, "Lights all askew in the heavens. Men of science more or less agog over results of eclipse measurements. Einstein theory triumphs. Stars not where they seemed or were calculated to be, but nobody need worry." So it's very reassuring as you drink your cup of coffee, you don't have to worry about the universe falling apart, because Einstein showed that it was just an optical illusion because of the sun being there. And it says also that nobody in the world could comprehend it, said Einstein. In fact, there's a famous story shortly thereafter that Eddington was asked, is it true that only 3 people in the world understand relativity? And Eddington said, I can't think of who the third person is. So, next. So, overnight, Einstein became not just the world's most famous scientist, but also seen as kind of a prophet, a mystical figure, somebody who would turn to for advice on anything, on religion, on philosophy, on life. You would just ask Einstein. He knew everything, according to the papers and according to the press. Next. So this shows Einstein's popularity. He got letters all the time throughout his life. This was from a little bit later in his life. I saw this in a Princeton museum, small museum dedicated to Einstein. Dear Mr. Einstein, I'm a little girl of 6. I saw your picture in the paper. I think you ought to have your hair cut so you can look better. Cordially yours, Anne G. Coxon. So this is one of many, many letters written to Einstein over his lifetime by children and people from all walks of life. And the wonderful thing is he responded to so many of his letters. He did not like the telephone. He did not like being interrupted in his work, but he liked the slow pace communication known as writing a letter. He loved writing letters. Next. So the connection between Einstein and Schrodinger, back to Schrodinger, was cemented when Schrodinger became interested in the atom. And Schrodinger had sort of talked to different people. He wanted to pursue general relativity, but after Einstein and a few others found a few solutions of Einstein's equations, it didn't seem like there was much more to do with relativity aside from say that it works. But quantum physics, which is the theory of the atom, seemed like a very promising area. So that's what Schrodinger turned to, and he became interested in the idea of matter waves. And he learned about these through Einstein. Einstein sent him a paper from somebody named Louis de Broglie, a French physicist, who developed this idea that electrons are these blob-like things that oscillate through space, matter waves. And the reason de Broglie suggested this is because if you take a wave-like thing and put it in a near a strong force, like in an atom, an electron in an atom, if it's a wave, it starts to oscillate like a string would if you pluck it. And it can only oscillate in different patterns. Just like if you take a guitar string and pluck it, you get different patterns of vibration. An electron would do the same thing. And these patterns correspond to the energy levels of the atom. And not to get too technical, but the atom has different energy levels. And that's why if an atom gives off light, it gives off light in different discrete frequencies, not just any frequency, but certain frequencies of light. It's because electrons can fit into certain energy levels. Well, Schrodinger was interested in developing an equation to explain these matter waves. So he decided to work on the equation. He was stuck, and there's a notorious story about him. So by this time, Schrodinger was married to a woman named Annie. But as I mentioned earlier, he was not very loyal. And the story is he got stuck on this equation and decided to book a hotel in a resort in Switzerland and invited one of his old girlfriends there. And we don't know what her name is, but supposedly something inspired him, and he became, all of a sudden, very, very quick to finish his equation, develop it in only a couple of weeks, which was pretty amazing, publish it, and this won him the Nobel Prize. So this girlfriend, unknown to history, was the muse that inspired Schrodinger. Next. So Schrodinger's theory was fine, explained electrons as these kind of blobs, these matter waves. But then there was another theory of electrons in which electrons were abstract things that jump from level to level. And that was Heisenberg's theory of electrons. And you can't have really two theories of the same thing, two theories of the atom, without finding a connection between the two of them. So what Max Born did, and Max Born was a famous physicist. He's also known as being the grandfather of the singer Olivia Newton-John. There's a little bit of trivia, quantum physicist. So Max Born reinterpreted Schrodinger's equation. Instead of being matter waves, he reinterpreted it as being probability waves. So waves of chance. The chance that an electron will be in a particular place, instead of it actually being there. So Schrodinger was really upset by this because he believed that things should be continuous and that things should be rational, not probabilistic. Next. Einstein was very upset too because Einstein believed in a scheme in which the universe was deterministic and there was no role for chance. So he famously would tell people again and again, God, meaning from his perspective, God was his shorthand for nature and natural laws, not a religious figure, certainly not an anthropomorphic figure, but rather just an emblem of natural laws, does not play dice with the universe. So what he said to Max Born is that an inner voice tells me that quantum mechanics is not yet the right track. The theory hardly brings us any closer to the old one's secrets. I, in any case, am convinced that he does not play dice. So shorthand is God does not play dice. And Einstein said this again and again to numerous people as a shorthand for saying that the universe is deterministic. Next. So by this time, Einstein was a professor in Berlin. Schrodinger got appointment to a prestigious position in Berlin too. So by the 1920s, mid-1920s, the two of them are colleagues in Berlin. So here's Berlin in the 1920s. So that's the famous Brandenburg Gate. And then down this street was University of Berlin, where they both worked. Next. So these were the philosophers that influenced Einstein and Schrödinger. They were both uniquely physicists influenced by philosophers. Einstein was influenced by Spinoza, who was a Jewish Dutch figure who equated God with nature and thought that nature needs to be perfect and that have perfect laws. And Schrödinger was a believer in the ideas of Schopenhauer, who said that there's something called will, which is almost like a natural force that pushes things forward in the universe. Now, both of them read Spinoza and Schopenhauer. Einstein and Schrödinger read both of these philosophers, but Einstein was drawn more to Spinoza. Schrödinger was drawn more to Schopenhauer. Next. So Einstein was aghast by the idea of nature having uncertainty. He also felt that his theory of general relativity was incomplete because it didn't include all the forces of nature. It included gravitation, but did not include electromagnetism. So from the mid-20s onward, Einstein's primary goal was to develop a unified field theory, also known as a theory of everything, which is an idea that all the forces of nature would be combined in the same set of equations. Some set of equations that would be compact enough that today you can imagine the set being small enough to fit on a t-shirt. Something very, very compact, concise. Einstein was hoping to find this by modifying general relativity, by adding some extra terms, tweaking it a little bit, and opening it up to electromagnetism. His secondary goal was to usurp probabilistic quantum mechanics with a deterministic theory that his theory would show would explain the atom. So he wanted to explain how electrons behaved in an atom in a way that was mechanistic, deterministic, and not random, using his theory. Next. So physicists embraced probabilistic quantum physics in the 1920s, and then later turned to nuclear physics. So by the 1930s, almost all theoretical physicists were doing nuclear physics. Before then, almost all of them were doing quantum physics with probability. So almost everybody turned into the probability camp because it seemed to work. They didn't have the same philosophical objections as Einstein did. Schrödinger, as I mentioned, he was a man of contradictions, so depending on which audience he was talking to, he kind of would give lip service to both chance and determinism. So we would kind of go back and forth on these. But he still thought that his equation worked better with matter waves, not probability waves. So Schrödinger and Einstein found a natural alliance in both refuting the standard, what became the orthodox quantum interpretation. Now, the physics community thought of Einstein increasingly as a relic because he didn't accept what seemed obvious to everybody. But the press still thought that Einstein was a hero. In fact, more and more, they thought of him as a prophet and somebody who was the wisest man of the mid-20th century. And so when Einstein turned 50, Einstein had he had been very, very sick. When he turned 50, he had just recovered. And in his recovery, he came up with an idea called distant parallelism. Now, probably none of you have heard of this. That's because it was a theory that he developed suddenly when he was recovering, and it was a mathematical idea about parallel lines. It changed general relativity around so that all its predictions were off, so it no longer predicted the right things. But he thought it would include electromagnetism, but it was just a mathematical theory. It wasn't really a true theory. It didn't have any predictions. It turned out to be mathematically invalid. It was just something that he was trying out. Nevertheless, the press latched on this idea, especially the fact that Einstein had just turned 50. Here it was, he turned 50, which is older than most theoretical physicists contribute. And nevertheless, he was developing this brilliant new theory that would change everything. Next. So if you look in the New York Times in 1929, there were 11 articles about Einstein's new theory. My guess is more articles than there were about the eclipse measurements. So this is something that was completely unproven, yet the New York Times latched onto us as a revolution in science. So there was an article which said, in the New York Times, it said it was by far his most important contribution to mankind, more important than his original theory. They interviewed a physicist from NYU who said that it would enable you to levitate and to fly to the moon through anti-gravity force. And then they interviewed a preacher who said that it was the embodiment of what St. Paul had predicted about the world, about unifying the world. So there were a lot of church sermons which said, like, Einstein's theory was, the way to unify the world. So it became this really, really big deal in 1929. Next. Now, even humorist Will Rogers, cowboy humorist, said, "This Einstein has proven a great comfort to us that always knew we didn't know much." So everybody got into the act, comedians. This was something that was, the whole public knew about. Nevertheless, within 2 years, the theory was disproven, discredited, turned out to be a failure. Einstein moved on to other theories, but the press would never recognize that Einstein made a mistake. You never find a word in the press that Einstein made a mistake with anything. They would just suddenly trumpet his new theory as much as they would do the old theory without saying, like, well, what happened to the old theory? Now here's the new theory. Next. 1933 was a very sad, frightening year. That's when Hitler came to power in Germany. Einstein was out of the country, fortunately. Einstein was subject to much anti-Semitism during the 1920s, even before the rise of Hitler. So he knew that once Hitler was in power, that he would be a state enemy. Not just because he was Jewish, but because he was a pacifist, he was a war resistor, and he was a socialist. There were many reasons why Einstein felt that the Nazi regime would persecute him. So Einstein renounced his German citizenship when he was abroad, renounced his ties to German organizations, and then Hitler, in turn, basically declared war on Einstein and said that he was a traitor, and this led, not just because of Einstein, but because of the rabid anti-Semitism, this led in April 1933 to laws in which Jews, socialists, communists, and many other people were fired from their positions in April 1933. Unless they happened to have served in World War I, they were temporarily allowed to stay in their positions, but then they would be fired later. So a lot of people left Germany, a lot of people lost their jobs in April 1933. Now, Einstein already had a position at the Institute for Advanced Study in Princeton, which is pictured here. So Einstein decided to just stay in the United States and stay in Princeton. Next. Now, there were opportunists during this time, including somebody named Friedrich Lindemann, who was a very wealthy German expatriate who was a professor at Oxford. And he saw this as an opportunity to find new professors for Oxford from Germany. So he got in his Rolls Royce and drove around Germany. At that time, they were still welcoming people from England. There was not a problem in 1933. So Lindemann would drive up to university. He would find the head of a department and say, "Do you know of anybody who was recently fired who might want a job at Oxford?" Well, he went up to Schrodinger and said to Schrodinger, "Do you know anybody who was recently fired?" And Schrodinger said, "Well, how much are you paying?" And he said, well, we have a grant, a corporate grant to fund these positions in Oxford. And Schrodinger said, well, how much is it in? And Lindemann told Schrodinger, and Schrodinger said, well, can I bring an assistant? And the reason Schrodinger said this might have been because when Einstein got the position in Princeton, Einstein got a designated assistant who was hired full-time to do Einstein's calculations. So Schrodinger said, well, I want somebody to assist me because I'm working on a book. The man I want is Arthur March. So if you can give me the salary, hire Arthur March as my assistant, I'll take the job in Oxford. Lindemann said, okay, I'll check. We have the funding. It's a deal. Be you and Arthur March. Well, what Lindemann didn't realize is that the only reason Schrodinger wanted to bring Arthur March is because Arthur March was a newlywed. He had a beautiful young wife. Schrodinger was in love with the wife, Hilda March. And at the time, Hilda March was expecting Schrodinger's baby. So this was very, very opportunistic on Schrodinger's part. But Schrodinger brought along Arthur March and Hilda March to Oxford. Next. So what happened in Oxford was kind of expected. The people in Oxford had mixed feelings about Schrodinger. On the plus side, a week after he arrived in Oxford, it was announced that he won the Nobel Prize. So Lindemann was ecstatic. They had gambled on Schrodinger, and the gamble paid off because he won the Nobel Prize. He was internationally famous. But 9 months later, Hilda March was expecting, or had a baby, I'm sorry. Hilda March was already expecting. She had a baby, and that would be Schrodinger's daughter, Ruth. And by their interactions, it was clear that it was Schrodinger's daughter. Everybody kind of knew. It was public knowledge. So Lindemann was very embarrassed, and despite Schrodinger being a Nobel Prize winner, the people at Oxford at that time, it was an all-male enclave. They were very stodgy, and they thought, my gosh, he brought Arthur March just because of a woman. My gosh, how dare he? So they decided not to keep him in Oxford. So Schrodinger started looking around for other positions. He got a visiting position where he would speak for a few weeks at Princeton. He went to Princeton and he gave a brilliant talk. By that time, he was a brilliant speaker. He gave a brilliant talk at Princeton. He was bilingual, so his English was impeccable. He used good analogies. The cat is only one example of the many analogies he used when he was talking. And he explained to them, they invited him for a permanent position. He explained that he wanted to bring along not just his wife, but another woman. And they said, no, sorry, we have bigamy laws in the state of New Jersey. So he didn't take that position in Princeton. Next. Rather, he took a joint position in Austria, which turned out to be a grave mistake because 2 years later was what was called the Anschluss, the annexation of Austria. Germany annexed Austria. It became a state of the German Reich, and Schrodinger was now in trouble. So he knew that he would lose his position. So he decided to cut a deal because he wanted to stay in Austria. Next. So he was asked to write a memo proclaiming his allegiance to Hitler. Now Schrodinger was an opportunist, so he said, sure. And he wrote this beautiful, flowery memo saying that he was loyal to the Fuhrer. Well, the next day, this was published in the Austrian press. And then the next day afterward, it was published in the international press. And if the people in Oxford were angry with him beforehand, they were even angrier. Here he was a refugee that they took in, and now he was proclaiming loyalty to Hitler. He did not believe in Nazism. It was purely opportunistic on his part. And he was fired anyway. He had to leave Austria anyway. So he had to flee from Austria. Next. Luckily, he had a mentor, Eamon de Valera, an Irish nationalist who was Prime Minister of Ireland, who wanted Schrodinger to be the Irish answer to Einstein. So he recruited Schrodinger through a secret letter that was sent to Schrodinger in Austria. Schrodinger accepted, but he knew he had to escape Austria to go to Ireland. And by that time, Austria was under the iron heel of Hitler, and it was very hard to escape. So Schrodinger had to plan an escape. Next. The escape turned out to be more dramatic than even the von Trapp family in real life. In real life, the von Trapp family, despite the sound of music, George von Trapp had an Italian visa, or Italian passport rather, and had a visa for the United States, and they kind of left on a music tour. But Schrodinger had to leave in the dead of night from Austria, travel on the train, go to Rome, where he wrote to de Valera, and they arranged to meet in Geneva, and then de Valera gave him a diplomatic passport, and he managed to get to Ireland. Next. So in Ireland, Schrodinger took up a position at the Dublin Institute for Advanced Study, which was modeled after the Princeton Institute for Advanced Study. It was a clone. Next. But Schrodinger knew that he had to be the Irish answer to Einstein at this new position. And he was very much indebted to de Valera and knew that he had to get funding for the institute. He needed to make a name. So he was constantly writing to Einstein and talking about his friendship with Einstein. So this is from the Irish press, picture of Schrodinger writing to Einstein. Next. And Schrodinger at that time, he was living with his wife, Annie, his girlfriend and mother of his daughter, Hilda. But the Irish press was basically controlled by de Valera, and every story about Schrodinger made it look like everything he did was wonderful and beautiful, including taking in a refugee woman into his house. Wasn't that wonderful? He took in a refugee woman and her daughter into his household. So that was how they treated him. That's his daughter Ruth, who's still alive today. She's in her 80s and living in Austria. Next. So Einstein and Schrodinger corresponded. Schrodinger wanted to work with Einstein on a theory of everything. They developed ideas that were very, very similar. They could have almost have been collaborators. Einstein called Schrodinger his nearest brother. They were so close. They would both critique quantum physics, make fun of standard quantum physics. Next. But Schrodinger was starting to betray Einstein. Einstein would write to Schrodinger confessing that he had some problems with some of his ideas. Schrodinger would take the letters, go to meetings of the Royal Irish Academy and read Einstein's letters and say, you see, I can beat Einstein because look, Einstein confessed that he can't do this, but I can do this and Einstein can't. The personal letters. So there was one such case where Einstein said that a certain idea, that he had buried it. It was in the graveyard of his hopes. And Schrodinger went to the Irish Academy and said, you see, Einstein said he had buried the idea, but I've resurrected it. Next. So in 1943, Schrodinger declared that he had a theory of everything, that it could explain fluctuations in the Earth's magnetic field. That turned out to be completely off. He just essentially made it up. He just kind of saw that there were some fluctuations and said, my theory will explain this. The theory was very close to one he worked on with Einstein. The press trumpeted it as a major breakthrough. Next. And they also published an article saying that Einstein had failed. Based on his own confession, he said that he had failed, but Schrodinger succeeded. So therefore, Schrodinger was better than Einstein. Einstein didn't know about this at this point. But then, a few years later, next, after working with Einstein some more on the theory, Schrodinger thought he had an even better idea. So once again, he went to the Royal Irish Academy, January 1947, and declared that he had a revolutionary new theory that went far beyond Einstein. Next. So in the New York Times was a headline, Einstein's theory widened. Scientists in Dublin claimed he has achieved the unified field theory that Einstein sought for 30 years. They sent clips to Einstein and said, "What's your reaction?" Einstein was furious because here they had been working together, writing letters every couple of weeks, and now the press was saying, "Well, how does it feel to have a scientist from Dublin beat you at your own theory?" And Einstein reacted. He critiqued the press. He said that they were too quick to accept new theories. Next. So this is where Schrodinger made the announcement. Next. And that's the equation he developed. Next. And Einstein basically said that the press was declaring revolutionary new theories about as often as revolutions in third world countries, and that this should not be. Now, what Einstein failed to say is that the press was doing it for his theories. I don't know if he would say the same thing about the press trumpeting his theories, but now the shoe was on the other foot, and the press was saying that other people's theories were theories of everything, and Einstein was really furious. Purportedly, they threatened to sue each other for plagiarism. And Schrodinger said, "What's the big deal? It was just a scholarly conference." But they were both very angry with each other. Next. But then a couple years later, both theories, Einstein's new theory and Schrodinger's new theory, were disproven. Einstein pursued into his dying day, finding a theory of everything. Schrodinger switched to philosophy and wrote books about ancient Greek philosophy. Next. This is Einstein's office on the last day of his life. He still has equations on the blackboard, which are a little hard to see, trying to find a theory of everything. Next. So in conclusion, the media was not very critical. They thought that Einstein's theories and Schrodinger's theories later, because these were great men, they should be revolutionary theories that did not look for evidence. Unlike the physics community, which was much more critical. The theory of everything, pursuit of it, went to Schrodinger's head. He became more and more egotistic. Luckily, he and Einstein got back in touch shortly before Einstein died, but it could have threatened their friendship forever. Next. So more about this is in my book, Einstein's Ace and Schrodinger's Cat. And after the question session, I'll be glad to sign personalized copies of the book for anybody who's interested for a price that's less than a list price. It's kind of the price I paid for the book, which is $25. And you can learn more about the life of Einstein, the life of Schrodinger, and how their friendship turned into a bitter feud, and how all this resolved. So anyway, that's the talk, and now I'd be glad to take questions. Thank you.
As you ask questions, you need to make sure that you have the microphone so we can get it on the video. Okay? Anybody have questions for?
So did Schrodinger have anything interesting to say about philosophy?
Oh yes, he published a number of books related to philosophy. He published a book called Nature and the Greeks, which was his take on Greek philosophy. He was very much interested in Schopenhauer, and that led him to turn to Eastern philosophy. So he's very much interested in Buddhism, the idea of continuity. He thought that everything in the world was interconnected, and that influenced his idea of physics, that things were interconnected. So he gave talks about philosophy, and I wouldn't say that he was a particularly original thinker, but he did have interesting things to say about philosophy, stemming from his readings of the Vedic writings and Hindu, Buddhist philosophy.
Did either of them stay in touch with Heisenberg?
Well, Schrodinger, of course, was linked with Heisenberg. Both of them won the Nobel Prize around the same time. And Einstein was critical of Heisenberg because of his belief in randomness. And later, Heisenberg stayed in Germany during the war. and was the head of the Atomic Energy Project in Germany, which was also sort of trying to develop a bomb, not very strongly, but sort of had made some steps towards thinking about developing a bomb. Of course, the Allies thought that Germany had progressed much further toward a bomb, so that was led to the Manhattan Project, which was stimulated in part by a letter that Einstein wrote warning about the German efforts. After the war, Einstein was suspicious of Heisenberg, but they did meet shortly before Einstein died. They tried to steer away from talking about politics.
My question is for Diane. Diane, did you recruit this wonderful speaker? And if so, how is anyone going to fill your shoes?
Well, thank you. That's really kind of you.
Did Einstein have anything to say about Schrödinger's cat theory?
Well, in fact, Schrödinger's cat was developed because the two of them had a correspondence critiquing quantum physics. Einstein had this idea of gunpowder, that a keg of gunpowder that's in a mixed state between exploded and unexploded at the same time, wrote to Schrödinger, and Schrödinger said, wow, I like the gunpowder idea. Here's an idea with a cat. So they actually corresponded. So Einstein, in many ways, influenced Schrödinger, and even with that, influenced Schrödinger. So almost, if you look at Schrödinger's life, almost every step along the way, he was influenced by Einstein after 1913. So that's why it was especially cruel that Schrödinger turned against Einstein and declared that he beat Einstein. Now, Schrödinger didn't really think he was hurting Einstein. He thought it was just factual, like, well, somehow I beat Einstein. It's kind of a miracle. In fact, that's when he started talking about divine motivations, like, well, God brought me to Ireland so that I could beat Einstein. I don't know why I beat Einstein, but I did, so here it is. So, yes.
Were there practical applications derived from the Schrödinger wave equation?
Oh, yeah. So you can find solutions, and those solutions basically can predict what types of light are given off by atoms, hydrogen, helium, and so forth. So then you can predict, you add an electric field, or you add electricity to it, add magnetism, do different things, and you can exactly predict what's going to happen, what kind of light you'll produce, and so forth. So there are a lot of practical applications to it.
Microphone, but I'll talk loud. Early on, you mentioned kind of the thought experiment of the sun disappearing, influencing, I think, Einstein's special theory of relativity. I wonder if, after his theory, is there any conclusion what would happen in that hypothetical sense? Because I know, I believe, for instance, in inflation theory, that space actually can expand faster than the speed of light. Would there be some sort of space-time wave that would propagate to, say, the Earth if it were to disappear?
Okay, well, that's an excellent question. So here's what would, so first of all, you allude to a few things. So there is a possibility space itself can expand faster than the speed of light. There's no prohibition against space itself expanding. But that would be sort of space as a whole on a very, very large scale. Much, 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 much larger than the scale of the Earth and the Sun and the solar system. The area of the solar system is not expanding. So you have the Earth and the Sun are in a stable orbit. Now, according to the Einstein theory, this is a gravitational well. So what would happen if the Sun disappeared? It would be like if you had a trampoline and you had a heavy rock and suddenly the rock disappeared. What would happen is the trampoline would slowly start to lift up, and that would cause a kind of wave that would slowly flatten it out, and then eventually it would become completely flat. Well, the same thing would happen. Space-time in the area of the Sun would start out curved, and then a gravitational wave, which is basically just a ripple, would travel at the speed of light away from that point where the Sun used to be, And that ripple would flatten out the space in the area until it was flat as a pancake. And then, as soon as it was flat as a pancake, Earth would move in a straight line. And that process would take about 8 minutes for that to happen. Okay?
I'll ask one more then question. I heard that Albert Einstein also was perhaps to a degree a womanizer. Is there any truth to that? You didn't mention that.
Well, that would be another talk, but he had 2 wives, not at the same time. His first wife, Mileva, was a Serbian woman, and he promised her everything. He promised her a very bohemian, modern, progressive relationship. But then, after she had kids, and basically he wanted, quote, traditional relationship where she kind of stayed home with the kids, even though she was a brilliant thinker, she was a scientist too. And then, shortly before they got divorced, she still wanted to stay with him because of the kids. He gave her an ultimatum, which was one of the cruelest things I've ever seen anyone write to anyone. I can't believe that Einstein wrote it. It was basically this ultimatum saying, like, you shut up, you never talk back to me, you need to just take care of the kids, do the housework, mind your own business, never interrupt me, and this whole list of things. And Mileva, the poor woman, agreed to it. She signed off on it, but then a few weeks later she thought, oh, forget this. I'm divorcing the guy. And she demanded for the divorce, to her credit, all the Nobel Prize money if he ever were to win the Nobel Prize. And then at that time, he was had an affair with his first cousin, Elsa. And after the divorce was finalized, Einstein married Elsa. And Einstein also had a number of affairs throughout his lifetime. But the difference between Einstein and Schrodinger is that Einstein was very remorseful and embarrassed, and he would write to friends and say, you know, I feel like my family life has been in shambles, and I really admire people who have been closer to their kids and have intact family lives. And Schrodinger kind of thought, well, this is just the way what life has brought him. Life has brought him a marriage. Life has brought him women who were interested in him, and that's just it wasn't his fault. That was his attitude.
How many children did he have?
Schrodinger had.
No, Einstein.
Oh, Einstein. Einstein had 3 children. One of them was his daughter Lieserl, whose fate is lost to history. Who was born before Einstein got married to Mileva. It was Einstein and Mileva's daughter before they got married. Then 2 sons. One of them, Hans Albert, became a physicist. One of them, Eduard, wanted to be a psychiatrist, but developed schizophrenia and was institutionalized, sadly. They didn't have the medications then. Otherwise, perhaps he would have had a career as a psychiatrist. He was a great admirer of Freud. And Hans Albert had a son, and that son had several sons who are still around today. One of them is a violinist. One of them is an anesthesiologist in California. So there are some Einsteins around today that are descendants. Now, Schrodinger had 3 daughters with 3 different women, none of whom were his wife. So, and then his daughter Ruth is still around, and he has a number of grandchildren. Yes, in the back. Oh, okay. Sorry.
So you mentioned the Schrodinger's, thought about his relationships, and then I hate to just keep harping on this issue, but was his wife complicit in this, or did she just? Was there any indication that she did not like this?
She was depressed. Much of the time, she was in ill health. Some of the time, she actually went to sanitariums to kind of recover. She supposedly had an affair with a famous physicist named Erwin Weil. But my guess is that was kind of a reaction because he made it clear to her that he wanted an open marriage. But at the time, especially in the 1920s, there was an attitude. It was kind of an anti-women attitude, but more like, well, man should have the right to have these kinds of affairs. And she just kind of thought he was brilliant, thought it was kind of sad. She couldn't have kids, and she knew that he wanted kids. She was very, very motherly to his daughters by other women. So she felt happy that he had daughters by other women. She was happy about that aspect. So I would say that she had a lot of mixed feelings. She thought he was brilliant. She said he was nice. They were close, platonically very close throughout their whole life. And in their old age, both of them were very ill, and they grew closer to each other. I hope I answered the question.
These models of infidelity.
Can we take this side? Seems like.
One more question.
Okay.
Well, I was going to ask something along the lines of that last question as well. It sounds like maybe that whole group of people would have done better today, where these presumptions about how relationships work are finally starting to break down a little bit. So I was going to ask about the husband of the woman that Schrodinger got involved with. If those two people stay together.
Arthur March?
Yeah.
Yeah, it's weird. So Arthur March was not really angry with Schrodinger. He just kind of thought, well, Schrodinger is a great man, and he was happy to be associated with Schrodinger. And he just kind of accepted it, as far as I know.
It sounds like there was definitely it was less an unpopular thing to do then, probably more likely to be accepted today. But I had another question about the Schrodinger's cat thing specifically. He used that as a critique of quantum physics, and yet now today it's kind of used as the example of quantum physics. And I remember reading at some point where he was upset that he had ever come up with that idea at all, because it has been repurposed into being used as an example of quantum physics to justify quantum physics, where his was to point out that it was ridiculous.
Well, what you might have read is he was upset that it had anything to do with quantum physics once it became chance, a probabilistic. He said something like that. But he wouldn't have said, I'm upset about my cat experiment being repurposed, because the cat experiment wasn't very well known in Schrodinger's lifetime. It was just a small part of a paper. And it became really popular with the internet. I mean, there were books about it starting in the 1970s, but especially in the 80s and 90s, there were some books. And then with the internet, it kind of caught on as a kind of meme. And then, especially in the last 10 years, it's mentioned on Futurama and Big Bang Theory and various comics and internet sites, and so a lot of websites and so forth. It's become a symbol of ambiguity. But this was way after Schrodinger died. He died in 1961.
Current quantum physics.
And I don't think it's being used. I don't think anyone would use it as a positive example of what quantum physics predicts. I don't think any quantum physicist would actually think if you did the experiment it would work. It's considered more of a kind of a joke or a ludicrous example of the misapplication of quantum physics.